Let's move on to our next project, which is the Classroom Learning and Assessment Suite. We have a number of different PIs with this project, including our own Professor Jesse Blocher, who is Director of Graduate Studies for the Data Science Institute, and is also Associate Professor of the Practice of Data Science and Finance at Owen School of Management at Vanderbilt University. We have Dr. Yaa Kumah-Crystal, who's a pediatric endocrinologist and also a professor at Vanderbilt University Medical Center. We also have, as one of our PIs, Professor Charreau Bell, who's a senior data scientist at the Data Science Institute, also an assistant professor of the practice of computer science here at Vanderbilt. And the lead for this project was also Professor Charreau Bell. Team, let me pass it over to you to introduce yourselves and to share what you've done with this project.
I'm going to go ahead and share my screen. Can everyone see that okay? Awesome. All right, so very excited to introduce AI-driven tools for classroom learning. So to begin, would like to thank all the team members involved in this project. This was a 10-week-long project, and so it was very, very exciting to see the progress that was made by everyone involved. So to begin, envision yourself as a professor or student immersed in the modern era of integrative AI. The rapid transformation of learning and teaching landscape might leave you awestruck. Many people are seeking a set of tools that meet three essential criteria. They are A, user-friendly, B, universally accessible, and C, significantly enhance the teaching and learning experience. This very vision was shared by countless educators, and today we embark on a journey to delve into the AI-powered tools tailored for classroom learning and teaching. So over here, you'll see an overview of what we're going to be discussing today. But basically, the Classroom Learning and Assessment Suite is a set of AI-driven solutions that complement in-class learning with interactive study and assessment. This suite creates new mechanisms for both students and faculty members in both supporting high-quality learning assessments and streamlining grading of student submissions using generative AI. So as we mentioned before, these were some of the PIs involved in the specifications for the classroom projects. So a little bit more about AI in education. It is a very personalized learning experience, and it can assist in the content creation, automation of tasks like generating quizzes, assignments, and even interactive simulations. As a professor, you have more time to focus on teaching while AI handles the routine tasks, and students can benefit from well-designed materials that enhance their understanding and retention of complex materials. So I'm now going to pass it on to Adam, who will explain an overview of the student and instructor interactions using AI tools that we designed.
Great. Hello. So the primary output of our internship was a series of tools that will allow instructors and students to improve their studying capabilities. They interrelate in a cyclical fashion, in a sense. First, the instructor would provide the students with some reference materials, like a textbook, lecture series, papers. The student can then use those materials in one of the applications using large language models to self-study. The student can then provide the results of their studying to the instructor, who can then assess their efforts using other large language model tools, provide feedback to the student. And throughout this process, the student is improving their own self-studying capabilities. Looks like. So, excuse me. So first we have, we split this up into two sections. First, we have all the tools that were used by students, and then we have all tools that were designed for the instructors. So in terms of tools for students, we have those divided into two separate categories. First, we developed a series of Python notebooks that could be interacted with in a programmatic fashion with a more customizable and accessible experience. Second, we developed a user interface that is more user-friendly and allows a deeper understanding of the text by engaging with the source output of the text. Can then export the chat history from the user interface for the subsequent instructor tools. I'll give a brief explanation of how exactly we are using a reference document in our large language models. So, so the most obvious way of including some reference inside of the prompt that we apply to large language models is just like copy it and paste it into the prompt, which would then feed into the large language model and get an output. So for example, if we could provide, we have this snippet of a poem, we could just copy that into the model along with our question, and then the model will then answer using that reference. However, if the reference, next one. However, if the reference document or set of documents is too large, then we can't pass in the whole text at once because it'll fill up the context, meaning we need to find another approach. And this is where vector stores come into play. The concept here is that you split up the text into a series of sections and then convert those sections into vectors. Then, when the user inputs a prompt, we turn that into a vector and compare it to the vectors of the sections by semantic similarity. We find the segments that are most similar and then combine those with the query and other information and pass it into the large language model to then get a result.
All right, so a critical aspect of this whole project was prompt engineering. And so this is very important when working with large language models like GPT 3.5, as it involves crafting effective prompts to elicit desired responses. So here are just a few examples of different prompt category or prompt patterns, as well as pattern categories. And so I'll give a few more relevant prompts that we used particularly for this project. So we have a reflection pattern that's used to better understand the large language model's rationale and understand why and how it produces a certain output. So an example of that will be the following, and I'll leave y'all to read it. Another one is the persona pattern, which allows people to tailor the large language model's analysis for the purposes that we establish. So for example, saying that you are an expert in so-and-so, and so make sure that you do this and this. And so that allows it to give a little bit more of a proper response and a more appropriate response in some cases. We have the recipe pattern, which generates a list of steps and asks the prompt to identify the most important / unimportant steps. So this can be very helpful for people's learning experience. Here's an example of what that could be in a self-study sort of sense. The next one is a question refinement pattern, and that ensures that the large language model always suggests a better version of the user's question. So asking for it to provide an explanation to the question and explain why and provide ways in which it can be improved. The flipped interaction pattern allows the user to ask questions until a certain level of comprehension is demonstrated. So it's kind of, again, works very well for self-study. And then alternative approaches patterns allows for the prompting of users to comprehend and analyze a text in different ways. So having a question and answer, having open-ended discussion. We experimented a lot with multiple choice. And so here's that example as well. So now we're going to play a few demonstrations of what we mean by these different models and notebooks. And so Eleanor created a great video. She could not be here today, but this is her explanation.
So one of the things we did before implementing the user interface was create these interactive student notebooks.
Oh, sorry, I wanted to make it better quality.
So the purpose of these notebooks is for students to interact with the model. They are a little bit more tailored towards students who are more comfortable with code or working in a code space. They are more customizable than the user interface and will allow the user to customize the code, amend it to whatever makes the most sense for them. But in general, this is also partially the back end for our user interface. So we started out with the prompt with context notebook. Now, the purpose of that notebook was that the user would just pass a simple text, so copy and paste text into an empty string into the notebook, and then they would be able to interact with the chat model through that. The prompt with Vector Store Notebook is a little more complicated than that. What it actually allows the user to do is upload a file or set of files in various file formats, PDF, text, Word, etc. And to be able to store those as vector stores through a module called LangChain, which works with OpenAI's API and allows us to query and use the capabilities of ChatGPT, in this case GPT 3.5, to ask questions about the text or the files provided. So quickly, I'm just going to run through this notebook. The user will just set up their settings, so like whether or not they're using Google Drive or local drive, whether or not they're going to be uploading a file or a zip file. And then once all of that is done, we have a lot of visual instructions to make sure that it's very accessible for the user. They are just going to put the file path there, and then from there, it kind of runs itself a little bit. And so they will also have to input an API key. That's another thing. But we also give instructions on how to get that key. And then down here is where the vector store actually happens. So depending on which type of file you're uploading, it will create the vector store respectively. And then here is where the user can interact with the model, like try it out, ask it a simple question, a complex question. And then down here, we get into our list of high impact prompts, which can be found on the wiki here in our repository. And I'm just going to quickly demo the multiple choice example. So you can see here, we're using Robert Frost, The Road Not Taken, and great, it gives us a perfect question reflecting our learning objective here. One question, just like we asked it to, and so yeah, that's how it works. And basically the only difference between this and our original prompt for context is that this allows user to interact with files, which is kind of like the preliminary stage to our user interface, which we'll go into next. So one of the things we did,
Sorry, let me move on to the next. Okay.
Second, here we have a reference for the user interface. First, you can upload a reference document, in this case, a textbook on utilitarianism. You can optionally provide a learning objective to help guide the model to focus on certain aspects of student learning. And first, you could directly interact with the model by asking questions similar to ChatGPT. After a while, provide a response along with some sources on the side, you can see here, taken directly from the textbook. In addition, you can also use our pre-made prompt generator. In this case, it's intended to generate questions that you can then respond to in the model. So here I have some multiple choice questions. Copy that prompt in here, respond. And then again, it will provide a question along with some sources from which the question was derived. Finally, you can see at the bottom, you have some methods to export the results of this chat, which can then be fed into the instructor notebooks, which we will discuss on in a future section.
Yeah, let me start with a short story. Like everyone here remembers those nights before an exam or presentation, the flurry of notes, the rehearsing, and the uncertainty. And what will they ask me? Now imagine on such night, you discovered a virtualized oral exam tool, an innovation powered by large language model and generative AI. You input your topics and immediately it replicates the challenge of your real exam, presenting you with the tailored questions and feedback. Your anxiety is replaced by the clarity, your doubts by confidence, and the unpredictability of next day's questions becomes exciting challenge, not a looming threat. By the time the actual presentation arrives, you're prepared, assured, and ready to impress, all the thanks to the night spent with a digital mentor reshaping the narrative of the night before. Motivated with the self-study and the high-quality learning assessments, Dr. Yaa and other PIs showed interest in oral exam models where students are assessed through verbal means. Furthermore, the conversation evolved into practicing presentations and even PhD dissertation defense, and how generative AI can help prepare such rigorous works. To address this, we introduced two distinct modes, the presentation mode and oral exam mode, and the core components remain consistent for those modes. First, instructions such as grading rubrics or foundational, I think you can go back. I'm still there. Yeah. Yeah, foundation knowledge will be provided. And the second, the generative AI would formulate the questions based on the instruction input. And third, the student can respond either verbally or written format, and the answer will be transcribed. And lastly, the generative AI evaluates the student's performance, offering the comprehensive feedback. Next, please. Yeah, this diagram illustrates the general flow of the two modes we discussed, and let me spotlight two key features. First, we have a developed iterative chatbot in a student answering. The chatbot poses a question, then the student responds. And this answer is fed back to the chatbot, which promptly provides feedback, and this cycle continues until all the questions are addressed. Second, we implemented the presentation mode. And it contains its unique feature. Instead of generating questions right away, students would first record their presentations, and generative AI then formulates follow-up questions tailored to the contents of the presentation. And Ricky will get into more detail about these tools.
So yeah, again, the first challenge for this oral exam app will still be how to transcribe the answer in a timely and accurate manner as we compare different models. Again, as mentioned in the IDA project as well, the OpenAI Whisper API and OpenAI small models work generally better, but as we consider accuracy, we finally choose the Whisper API. So now let's move on to the actual demo for this app. So as you can see, you can input your API key here. And you can also upload the context or like the background information for the presentation down here. This could also be the grading rubrics. So in this case, we will just use a poem by Robert Frost. And then you can see the two tabs. You can do the presentation mode or oral exam mode. And here you can upload your presentation, or you can record your presentation. So here I just record one sentence, but you can also record for like 20 minutes or so. The following section will be the instructions for the question answering part. This will be optional, but you can also add like a grading rubric or guideline for the QA section. And once all those are done, you can generate your questions. And this will be based on the context and your presentation and the instruction for the QA section. And once you're ready for the QA, and you can also upload your own questions list. You click I'm ready, and now you can interact with the chatbot. So can you elaborate on how the poem represents decision-making? And you can record your answer, or you can type your answer as well. So here you can see once you're ready, recording your answer, you can submit. You can also type in your answer. Sorry, I just used, I don't know, but you can definitely answer that as well. So once everything is done, click the done button and you can get your overall evaluation. But keep in mind the chatbot functionality will give you feedback for each question as well. So this is a presentation mode. The only difference between presentation mode and the oral exam mode is the presentation mode will have a presentation section, but oral exam does not. And here you can see the evaluation down here. So for the oral exam mode, the question generation section is also different. There will be more options. You can choose true or false multiple choice short answers. You can choose the number of questions and how long will that be for the short answer questions. But everything else will be the same. And the chatbot functionality will work exactly the same. So that's the brief demo for this oral exam app. And this can also be used for instructors if they want to use this during the class for in-class feedbacks. This will also work.
So now moving on to tools for instructors, we'll first be discussing Bloom's taxonomy as a rubric that's used to assess students. As you can see on the right, it's a hierarchical model that offers instructors a structured way of evaluating the level of a student's understanding of a certain concept. So with this in mind, our instructor tools utilize prompts based on each tier of this model. And we've seen previously how students can self-assess and even export the results. So how do you as an instructor interact with this data? We envisioned that students would submit chat logs through Brightspace. The instructor would then download the files and perform AI evaluation to receive feedback and automated grading from which the output can be taken to be uploaded to Brightspace for grading. And traditionally, instructors would have to spend hours, maybe even over a couple days, reading and analyzing student assessments in order to assign scores and respond with feedback. Our instructor tool streamlines this process and automates it such that it can be done in mere seconds or minutes, depending on the file size. So let's take a look at how this works in action. So let's say you're grading a batch of zip files. So here you upload the file, and once you click submit, you'll be prompted with a status message showing successful extraction. You'll want to enter your API key and then run the subsequent grading cells that format the files and prepare them for large LLM evaluation. And for this example, included a series of short answer responses. So as discussed earlier, we'll be using Bloom's taxonomy to grade this work. And it will iteratively call the model to evaluate each of the results, including providing feedback on what the student did well as what might have been missing from the response if the student did not receive a perfect score. So as you can see, for each of the responses, there's a summary as well as the feedback. Now with this, all of this is stored in a singular evaluation log file that the instructor can later access, as well as running this cell below will save all the student responses if you want to view them. So once this processes, we'll go to the files, and here you can see the evaluation log text that stores all the results. And then the subsequent file containing all the student results stored in a CSV. And then I'll take it to Adam to talk about the reference.
So finally, another tool we created for instructors was a notebook to create collections of refer documents for self-study with LLMs. So as you saw in the application demo, if students are intended to use a certain document for reference, they need to upload that document themselves. And this can get tedious as the number and size of the reference documents grows. To remedy this, we made an easy-to-follow notebook for instructors, which allows the instructor to upload all the documents at once and save them to an external vector store database, specifically using Deep Lake. And they receive a URL which they provide to the students, which the students can then use to automatically reference all those documents in the database. This process also allows instructors to upload non-traditional text documents like YouTube videos and websites, which are then converted into a text format in the database. Now I'll hand it off to Kevin for the conclusion.
Yeah. So at the end of our day, our tools provide user-friendly interfaces that allow both students and instructors of all backgrounds to interact with large language models in a way that's very accessible, which also allowing students to engage with AI, to self-study and ask questions. Our instructor tools significantly reduce the amount of time previously required to evaluate and write detailed feedback for what might have been low-stake assessments, such as homework assignments and short essays.
We've also identified areas for improvements in our future for the tools, and then evaluating various LLMs like GPT, Cloud, and BARD to select the top performers would be another task. And the many modules contain redundant code, and our goal is to streamline this by creating libraries or functions, enabling functionalities with simple commands. And this includes tasks like loading files, inputting the setups, and the prompt templates. For the oral exam modes, we need enhanced prompts and increased collaboration with instructional notebooks and instructors. Our chats sometimes provide feedback even without the answers, and we will address this issue in the future. We aim to integrate our tools with Brightspace, where most of the assignments are given and graded. And our future goal is to auto-evaluate assignments and updating student grades and feedback seamlessly. Yeah, this is the end of our project. Thank you.
Fantastic, but a huge amount of work. Let me go ahead and open up the floor for questions or for comments.
Well, I also just want to say, like some of the other PIs have, that they did a great job. Like, I mean, I'd seen some of this before and some earlier iterations, but I think that it's a great set of tools that I think has a lot of a very wide range of applications for lots of different use cases.
So let me ask the team this: is this kind of work only going to be appropriate for use in technical classes? Or could it also be used in humanities classes?
Well, it definitely can be used in a wide variety of classes, as we showed in the demos. One of the primary reference documents we were using was a poem. So clearly, in that case, it can be applied to humanities classes, as well as other more scientific disciplines.
So pretty much these tools then can be used by anybody teaching classes where they want students to engage with and understand material, be able to self-test, being able to quiz themselves. And I'm just thinking about all the presentations I had to give and sort of try to guess what questions I might get. And I love the idea of that presentation mode, being able to just submit what I've written and say, ask me the tough questions. As a matter of fact, I probably could use that right now, as a matter of fact, for any presentation that I give. Terrific. Thank you so much for this work. I think it's going to have a huge and wide impact. And Katrina, I think that you specifically are mentioning Dr. Bell. Dr. Bell, I don't know if she can get on mute right now. She's actually in a conference, probably in a meeting right now. But absolutely, terrific work. Congratulations, team. Thank you for all of your work.